Hey everyone, welcome to this video. From this video onwards, we are going to practice surfacing. So we are going to work on plastic models, then we are going to work on foam models also. So we are going to see the method first. So you can see on my screen, if you talk about this plastic models creation, we can divide this modeling into three types. So the first is just closed body. You need to just do a closed body like 2 mm closed body, 3 mm closed body out of the plastic surface. Okay, so A surface you get from the customer, and from that A surface you create a B surface, that is just a closed body. Okay, so we'll see step by step. So first closed body is, if I expand this, there are methods. If we are talking about the closed body, then the methods to create a closed body, there are three methods that you should always try. These all three methods. So try with first method, then if first method is not working, then go to the second. If it is not working, then go to the third method. The first is direct closed body. Direct closed body means, if we see here, suppose just assume I don't get any problem here in this surface. So this is called A surface. Whatever surface I have offsetted, this is called B surface, and surface joining to this A surface and B surface, that is your C surface. So general method, we are going to create all three surfaces every time. We get A surface from the customer, we create a B surface out of it, and to join A to B we create a C surface. Okay, this is the normal process to create a plastic model, to create a closed body. So the first method is, suppose if you got direct offset without any issues, so in that case you are directly creating a C surface there and will do the closed body. That is the first and simple method, and you should try that method first before moving for next method. Okay, so that is the first method. If that method is not working for you, just check second method. Second method is direct closed body with minor correction. So after offset, if I get some of the patches, like some, you can see there are some of the patches, and if I am confident about that patches, after offset, if I get some of the patches in the surfaces, and if I am able to patch that or fill that patches after the offset, then that is the second method. We can go with that. Okay, after the filling some of the patches, you can go with that and you can create a C surface and closed body. That is the method number 2. Then method number 3 is a closed body with a separate surfaces. If you feel that it is not good to have these surfaces closed, so in this case I should go with this 3 number method, because you can see I have offsetted the surface, but again we got error in that, and what are the offsetted surfaces I have received, you can see this type of the surface is there. So if I consider to fill these patches, so it will take my more time, and again it will affect the quality of surface. So instead of that, I would like to go with the third method. Third method is create a separate surfaces. Instead of direct offset, I'm going to extract these surfaces separately and offset it. After that, I'm going to extract these side surfaces and offset it. So I'm going to do separate offset there, and after offset I'm going to do trim again. So in this way, this surface will not fail in these critical areas, and will get a closed body out of it. So every time you have just 3 methods. Whenever you get an input to create a closed body of suppose 2.5 mm, 3 mm, 4 mm, whatever it is, so you need to follow this step. First step, just directly try with the closed body. If you can directly offset and do the closed body. If it is not, try to repair offsetted surfaces. If you are getting any patches, try to repair that. And again, if it is difficult for you for the second stage also, then skip your offset, directly offset. Let's just create surfaces first. What are the surfaces you have, create those surfaces separately by doing extract, by using extract command, and after that just try to offset whatever surfaces, or try to offset individual surfaces. to get your closed body. So this is the method you should follow for every time while working on the plastic closed body models. I hope it is clear, right? Now second type of the work in this closed body is you need to close body with master section. So it includes the first process also, because we need to do the closed body, but you have extra master sections also. So I will show you an example here. So you can see on the screen, this is one of the plastic model, and you have input of only master section. You got only master sections, so that you need to calculate the thickness from there, or you need to maintain those master sections. So these are the sections we received from this surface, and sections we received from the customer, and the sections are dependent on the interfaces, right? So at which location your part is going to assemble, considering that all the interfaces, your sections are generated by customer, and we have to follow exactly those sections. How to follow that? So target is after your closed body. If I take a section here, that section and this input section, that should exactly match. Okay, and the catch is you cannot directly offset here. You can see there is a variation in this thickness, right? So in this case you need to create a combination of offset and these surfaces, okay, because as output we need this master section as a output, right? Your model should match to this master section. So this is about your closed body with master sections. Again, there are two sub methods for that. You can see on the screen: direct closed body and create other features per master section. So sometimes we received only, I think I have another example here. That will not work. Okay, so sometimes what happens, master section requirement, they will show only some of the features on the section. So always you need not to create those features into the surface. Just go with the closed body. First you can do the closed body at that time, and after closed body you can create extra bodies of the features what you have shown in the master section, and then add those body to the main body. Okay, so you need not to create extra features in the master section in the surfacing. So this is your second type of the plastic models creation. Third type is quite complicated, and as of now in this training we are not going to see that. Okay, I'll just give you a short summary out of it, short overview for that, so that in actual company whenever you work, you will work on that. So closed body with environment data. Sometimes we get a surface as an input from the customer, and along with the a surface we get environment data also. Environment data means the interface where that product is going to attach. So customer gives us, take this surface, take this environment, and just create a plastic out of it, so that we can attach this plastic to that environment, to that assembly. That is the customer's requirement. And then once you get a surface, it's our responsibility to create a closed body out of it and to create interfaces with that environment data, right? So here we are not going to see that, but closed body and the features directly dependent on the interfacing environment. It is not, you will not get any master section there. So you need to decide which features to use, how to attach that plastic to that environment. So we need to decide that, and prior to that we need to complete our closed body task. Okay, so these are three main methods, and we are going to work on two methods henceforth in the plastic models, practice models. So just keep this in mind. I hope this is clear, and while doing the modeling of any plastic part you should follow these steps. Okay, so thank you so much. From the next video we are going to start practice model 1. Thank you.